Our cam is always perfect, but sometimes, just for practice, we like to make some changes during a run. Laughs to self. Okay, like everyone, we make plenty of mistakes in setting up a job for the CNC. Typically, that would require a trip back to the shop office, which is on the other side of the shop from our CNC, to make those quick cam changes. Yes, we have Fusion on our CNC PC, but while that worked back in the garage days where just I was working on that computer, now it's just not a smart move to be running your CAD cam on the same machine that controls your CNC. Just too much going on. We've also never really had a proper place to put our tool holder, tightening vise, or a place to organize the tools for the next job. So, we made this cam station for only $196.69. Nice. Because labor is free, right? It uses an IKEA desktop, some steel tubing, Fusion 360, and a CNC router for added flair. I want to take you through the design and build process, so let's do that now. The design of this table is mostly about function. Primarily, we wanted to add a work surface for a CAD CAM computer and tooling setup. This would condense floor space by putting our tooling cabinet under the new work surface. It would also bring all of our CNC tool setup things to one place, a station if you will. They were previously in multiple places, not very lean. In terms of materials, the frame was built from steel tube. The wood top is a tabletop from IKEA that we just cut down and repurposed. And the bottom shelf is some AC pine plywood we had in the shop. We took the wheels off the Harbor Freight blue cabinet we used for tooling and it slid into the bottom shelf. That was by design. This did not need to be complicated in any way, but it felt like a great project to showcase Fusion 360's different workspaces from design to cam, drawings, and a bit of rendering because I just can't not render a project. For this project, I'll show you a replay of how we designed the cam station in the design workspace in Fusion. Let me drag the timeline back to the start. This is one of the most powerful parts of Fusion. It lets you go back in time to edit one small aspect of your project. You can get the Fusion file download as a member of our Patreon, link below, or head over to CNC Money in your browser. The first step was to model the 22-inch blue Harbor Freight cabinet accurately. So starting from the bottom, we drew the bottom footprint of that blue cabinet. Let's open up that sketch. That's the base sketch of the cabinet. And from there, we kind of started the rest. So I made a component here. That's what this little guy is. You do that by going to create new component or right-clicking here and click new component. So we called that Harbor Freight cabinet. I want to activate that so that we're working within it. The next thing would be just to extrude, which is this, what's going on down here. I extruded the cabinet up and I did a formula here that said cabinet tall minus the caster height. So that's kind of how I figured out what this height should be. Next is a sketch inside the component for the front because I wanted to be able to see those drawers because they look kind of nice and it's just weird to see a box otherwise. And I believe I made that look a little more accurate. Just did some extrusions with a little bit of a gap offset. So let's go back to the main component. And the next thing we did is make a sketch of the base. So that would be like all of the stuff, this is something we do often, so all of the stuff that you want in one plan view or something. So you start in a view where it makes sense to kind of draw a lot of the stuff that you want to use to reference throughout. I usually put that sketch in the top sketch like I did here, so it's not connected to one of the components because you're going to reference it in multiple components. Next is creating a new component for the steel, which I kind of just lumped into one big component as all the steel was going to get welded together. So you could have made each one a separate component. You can see down here we've drawn pretty accurate representation of the steel walls here. I think it's a 16th or something like that. 065 steel. And those are all drawn as a mirror, which we do often too, so that everything mirrors about these two planes. So you really only draw half of this and then mirror it over to the other side. There's that sketch. So then when we're in the steel component here, what we did is extruded all four of those uprights, and that goes to a height that we predefined from the parameters. So top minus top thick. That's a funny name for a parameter there, but that calculates out to 40 and 7/8, I believe. This is doing a calculation for me because I knew the top would go on top of this, the wood top that is, and I wanted the top of the top, which is why I called it that, to be at a specific height. I knew that height that I wanted, so we're kind of working backwards from the top of the desk kind of down. The next thing was to extrude these tubes. I offset it up with this parameter called below, which just gave it this little bit of gap. So it starts from here and moves up. Let's see what that is. So 3 inches. Go back in there. So if I would say 0, it would start down here and move down. But instead, because we're doing a negative tube section, when we offset up 3 inches, that's the height we want to start at, and then we wanted the extrusion to go down tube section, which is, I believe, 1.5 inches. And then, oh, I did do a steel shell. So this, as a separate body here, instead of connecting it, then you can shell out the steel, which is a command to essentially just make these hollow inside, which is a cool little feature. And we use steel wall as the inside thickness. And I selected all those faces to get that. Next, we did the same thing with the steel in the middle, extruded, used below and tube section, shelled that out on the inside there. I think we added one more. Oh, we added the upper ring, which just includes the same idea, using that bottom sketch to project from. We used more things to offset with, so use the top minus the top thickness, and then the tube section to kind of get where we wanted to start that, and then extrude the tube section. You can see up there, these pieces were made. Shell that out, and we've got our steel. So back to the main component, pretty basic, and steel is pretty easy to model, so it's just definitely something that looks really nice, and I like to have it accurately represented. Next up, the beach top. So I created a new component, right, like that, and named it Beach Top, which this is the IKEA desktop that I picked up before the pandemic started. That's just a quick model of an extrusion, again, projected from the bottom. So a lot of my work of a sketch goes into kind of refining this bottom sketch, because I knew everything could be drawn from that one sketch for a lot of this basic stuff, and we know exactly how it's going to fit that way in relationship to each other. You could do multiple sketches. I sometimes like to just throw it all into one sketch. It's something that seems to work out. The top here is top thick as a parameter, so that was 1 1/8. And actually, I think I guessed at this at first. Because of using parameters, I can just open up my parameters and find top thick when I actually got it, and I measured it out so that I could accurately CNC it. Let's go back to the main component. So we extrude the top, then I believe I just kind of left that for a bit, left it real nice and simple, and we created another component called that bottom ply. As you can guess, we made a little plywood piece down here at the bottom. So let me turn this cabinet back on. You can kind of get an idea of how this is all fitting together. The cabinet fits in so that you can slide it in, and you still get the proper height you wanted on the top. So that was kind of an important couple of dimensions of how high off the bottom we were, and then how tall the cabinet, the width of the cabinet, and then what we wanted for the upper height. So these little pieces are just modeling up that vise mount so that I could have an idea of how it would fit. We ended up not doing the side panel, so I'll kind of skip this part. And the vise is actually mounted about right here. Anyway, this is more vise stuff. Just getting a nice accurate model of that. It's actually what came with our machine. I think it's made by HSD. Threw a tool holder in there. And then I threw in our CNC cart that we designed, just to get an idea of how this all fits together, since this is the exact kind of representation of how we wanted to use it. Inserted the monitor mount. I just don't have it in hand yet. It's not something we have. So this is kind of how we intend to use it, is to have a little monitor to set up a computer that mounts up underneath here. Keyboard on the top, so you could move it around as you're setting up your tools, or you need to quick change some cam. You have a quick access to that. I started to throw some features onto the top here. So gotta have your fillets, and I'm gonna add some features to kind of simplify some things. So I had a good idea that we were gonna put some cords through here, keyboards, mice, the monitor cords, just anything like that. So that I felt like a good cord drop made sense there, and it'll probably run into the computer like bay here that we end up putting in. This was the bad first version for a big old tower. I don't think we're gonna do that, but you can kind of see. And then threw another one over here in case we maybe put the microscope here, or I'm not sure, something else, maybe some charging cords, like a little charging adapter setup. So the second part, I ended up not doing this too. These were kind of intended to be like a place to keep pens or clutter, and then I thought, well, that's just going to keep clutter and dust, so we just didn't do those, but I still modeled them out. Rounded things off, drew this pipe in here. It's kind of ended up being a bust, but I liked the concept. I think we just needed to do a little deeper, but the idea was to boolean out this pipe with a big cove cutter, as you see here. So I drew a sketch to draw the pipe, moved it up a little bit, and then did a boolean. So it looks great in the model, and it looks like it would do more than you'd think, but it's almost imperceptible, and it definitely doesn't do what I wanted quite as well. As if something was rolling, it would stop it from completely going off the top. You'll see later on, it wasn't quite as good as I wanted. Threw some fillets on the top. We're not going to actually cut these fillets on the machine. We'll do them with a hand trim router afterwards, but I think it's important to really see what you're going to make, and that's kind of one of the beauties of Fusion. So that's pretty much the whole design. This has been really great. One nice place to kind of set everything up. At this point, let's jump over to drawings, which we use for fabricating the steel and having as a guide in the shop. So when you open up the drawing we've already made, as you saw, it's in the browser window or the data panel over here as a separate file. Go down here in the bottom, you can see there's all these pages that we've made, drawn out all the details to kind of have a good idea. It's a nice thing to have. It wasn't exactly necessary for every little piece, but it's fun to be able to draw the details out of exactly what you want to make and have that in advance. Or if you're sending it out to the shop and somebody didn't work on this that drew it, obviously they need to know all the details. So it's very nice for that kind of stuff. This is just the steel portions. Drawings are okay in Fusion. They're definitely a work in process. As a past architecture grad, I can tell you there's a lot of things I'd love. I'd love a lot more line weight control. I'd love to be able to control a lot of the styling of things like the arrows, and to be able to have like proper headers that are a template and not something that you have to create every time. But that said, it's pretty nice to have built into the software and not have to go somewhere else to generate a drawing. To create a drawing from something you've already made, you just go back to that file. At the top here, I right-click and create a drawing. It's going to ask you what you want to make. I'm going to just let it say full assembly. We're going to create a new drawing. We're going to do from scratch. We have a template that you saw there. 8.5 by 11 is fine. Choose your standard. Doesn't matter. For this anyway. So you're going to see this kind of template that Fusion gives you. You can make your own, as you saw ours. And the first thing you're going to do, it wants you to place the models that we just said we wanted in here. So I'm going to click here, and I want that to be the front view, which is fine, but you could change it to be the top. The top. You can see there, we get a top view of our project and kind of a sketchy view. We're going to keep that at the front, and then we'll just leave the scale for now, but you can change the settings of what it looks like. It's just going to be a visible edges drawing, which is pretty nice. To make more views, you would use projected view. The base view is what we just put in there. You click projected view, and then you click what we're going to select from. And as you drag around, you'll see that it's giving us the different views we have of our project as a projected view. So top, that was the right, bottom, top. If you drag up into the corner, you're going to get axons, which is pretty cool. Axonometric drawings. This is pretty fast, and what's cool about this is every time, just like everything in Fusion, I pushed escape to get out of that. Just like everything in Fusion, whenever you update your model, it'll ask you up here in the corner. So if you go back to our drawing, it's saying, hey, do you want to update this? Because the model has actually been updated. And what's nice that it's separate is that I actually don't want this to be updated. I like it kind of being saved in this other state. That's a very nice feature of kind of having versioning that's on your own control. You could hide or show all these different things. Like obviously we wouldn't want the CNC card and all these. So you can quickly see how fast that was to drop all these in, and they're all relational. So The first thing you typically do is dimension some stuff out. Let's get the dimension of our top on there real quick. That's a weird dimension, but whatever. So it actually will resize. You have to be pretty precise about your selection, because if I change any of this in the drawing, that didn't even work. That's why. Dimension again. Select that tangent point, that one. There we go. If I change anything in the model and we update it, our link, it will update the proper things if you've actually dimensioned them right. I'll just throw a few more in for an example. Yeah, pretty fast way to create what you're looking for. You can do detail views, you can do a section. I showed that kind of in another view. So if I click that one, push enter, we're getting a section view. I drag that out and it should have a really weird scale of section and hatch pattern, but it worked. You'd have to go through and select these and change these. I wish you could scale them as a whole. Pretty cool little sketch there. So you could make another page, drop some more base drawings on. If I wanted to start from the top view this time, and I wanted it to have all the shaded patterns. Now when I do a projected view of this, it'll keep all those settings. So there's quick drawings. If we go back to ours, to output, you can get a PDF, a DWG, or any of these other options, and then you can print that and use that for yourself. Let's jump back to our model. Let's go use these drawings to build the steel frame. We recently picked up a used Hobart 140 welder and an Evo saw. Without these two tools, we probably wouldn't be making a metal base for this table, but they've been pretty great and fun to try out something new in the shop. The saw started out on the ground, but we quickly got a saw stand built too, which has been much more pleasant to use than kneeling on the ground. I've been trying to think of something smart to say about melting steel together, but honestly, there's not too much to be told, and we're not experts at that part by any means. You melt it together, then grind away your dirty work. Profit, right? In a few hours, we got the frame cut and welded together. Here I'm adding some angle iron with an elongated slot to allow wood movement in the top. I wasn't too unhappy with the welding quality since I hadn't done it in a few years and I'd never really welded with flux core wire. We're going to end the first part here. I thought I could get this into one video, but it's turning into a saga, and this way you have something for next week, right? So come back next weekend, I'll have part 2 where we do the cam infusion, CNC the top, and get this table put together. Let me know what you think in the comments. Look below for links to all the tooling and stuff we used. Lastly, if you want to get this model, join our Patreon at cnc.money and download that Fusion 3D file and also support us. Catch the rest of this project next week and turn on those notifications so you don't miss it. Thanks.